Yes. Hello, friends. Last time, we talked about floating point number variables. Now, from here on, we'll be dealing with character variables. Here, basically, we have a single variable that represents texts or characters. And that's the char variable. But there's also a broader, more advanced, and improved version of this. We'll talk about that later as well. So, here, the very first and fundamental one of our character data types that we will be exploring is indeed the char variable, my dear friends. This char variable, which is a crucial data type in programming, specifically and precisely represents individual characters within our programs. The char variable works the same whether you're on an application, Windows, Mac, or Linux, it doesn't matter. It's the variable that carries and makes sense of all the information you enter via the keyboard. Now, here we need to get into the logic a bit. So, there's this thing called a character. Okay, but what does that actually mean? I mean, defining and using it is simple, friends. Here's how we define it. Just like our other variables. Here's how you define a character variable, friends. You write char. Character equals. There are two ways to assign a value to this. The first method is to directly assign the character itself. For example, I assign the letter A like this. A is a character. I assigned it to that. Or let's assign it with another variable, or rather, with another value. For example, a question mark. That's also a character. What else? For example, 6. Friends, 6 is also a character. So, how does this work? But I mean, 6 was a number. Teacher, why did you write it as a character? Why did you write a? You wrote a question mark. What is this? What's the logic behind this? The things we see on the screen, the things we see as text, the things we refer to as letters, numbers, special characters, dashes, question marks, periods, semicolons. All of these are recognized as characters by the computer, and they have a certain standard. Now, think of it this way. The things we call numerical or numbers, friends, numbers exist because we know them and use them this way. In other words, people have called these things numbers and used them as such. There are also Roman numerals. They don't look anything alike, but they're also used to represent numbers. Isn't that right? In the same way, we're talking about letters. What do the letters in the Latin alphabet we use here represent? They represent the languages we are currently speaking and writing. But these aren't the only ones, are they? For example, there's the Greek alphabet, right? Besides that, there are different letters in Arabic, aren't there? They don't match ours. Or there's Chinese, right? In those too, look, there are different letters and many things are expressed in different ways. So, just because we call these letters or we call this a number or a digit, it doesn't make it something different. All of these are characters. The computer actually perceives everything it can show you here, everything it can draw the shape of here, as a character. Now, we need to talk about this a little bit. Friends, let's move a bit forward from the way the computer works and talk about this. I'm going to break the computer down into parts like this, okay? Let this be the monitor. Alright, this will be our case. Let's make this our keyboard over here. Alright, this is the keyboard. Let me write on these. It won't be fancy. Keyboard. Let's do it like this. This is our PC. And this is our monitor. Now look, you pressed any key on the keyboard. Let's say you pressed the letter B, for example. The B key you pressed will be entered as one of the computer's inputs. And inside the computer, this will go through a series of processes. Then, from this output here, this output is called Video Graphic Adapter, friends. You can also call it VGA or graphics card. Graphics card. Certain parameters are sent to it. It uses these parameters to display an image on the monitor. Now, let's think about the whole system end-to-end, how it works. All the keys on the keyboard are characters, friends. Each of them is a character. So how does the computer know which key you pressed? Now, think of it like this. How many keyboard manufacturers are there in the world? A lot. Do they all just send the letter B however they want? For example, do you think they send the letter B when B is pressed? Or do they send a combination of numbers to the computer when B is pressed? Now, what does the computer understand? Ones and zeros. So, when you press the B key, there must be a special number so that it can be transmitted as ones and zeros. And the thing that corresponds to this is the ASCII character table, friends. These ASCII codes store the numerical values of the characters you know, their equivalents in decimal, hexadecimal, octal, or binary systems right here. Now, when we look here, where is our lowercase b, for example? Here it is. Look, what is the equivalent of lowercase b here? It's 98, for example. In the decimal system, its equivalent is 98. So, when I press B, the number 98 is generated, and this number 98 is converted into ones and zeros, into electrical signals, and sent to the computer. In other words, when you press B here, you're actually sending a sequence of ones and zeros to the computer like this. The computer reads this incoming information and determines what should be displayed on the monitor. For example, what needs to be displayed? The letter B needs to be written. So, how is the letter B written on the monitor? Guys, inside the monitor, there are little boxes like this. You call these pixels. You know, there's that question, what's your resolution? It depends on how many pixels you have. Like, I use Full HD, or 2K, 4K. What determines those? They're determined by these boxes horizontally and vertically, guys. Inside these boxes, so inside each of these little boxes, there are things like this. What we call RGB. You know, what we call the primary colors. Here, it's going to be a blend of red, green, and blue. What do I mean? For each of these colors here, there are values ranging from 0 to 255. Guys, 255, 255, dash, 255. So, depending on the ratio of each, they're combined, and a color is produced at this pixel, at this point. For example, what are you going to produce? Let's say you're going to produce the letter B. Do you know what this does? It says, this part is 1. I'm just saying, it says, this part is 1. Then, Well, of course, since I can't write things very neatly here, it might be a bit hard to get a B out of this. Let me just scribble it like this. Imagine I've scribbled it like this. So, what happened now? Now, write the letter B. Of course, as the number of pixels increases, the sharpness and clarity get much better. I mean, when you look here, you don't really see much. But here, well, there's no problem here. But here, it looks problematic. Why? Because I don't have enough pixels. If I had at least, say, 25 or 30 pixels, or 50, 100, I could draw the letter B much more clearly. That's basically the idea. So, the graphics card tells these little boxes you see on the monitor which color and which shade they should light up in. So, when you see black here, it's actually giving you that shade of black. You see the colors. The graphics card knows which color should appear in each of these boxes here and sends that information to the monitor. And the monitor knows exactly where to light up those ones and zeros it receives from the graphics card, guys. So, the basic system, the logic behind characters on a computer is essentially this. Now, let's verify this. Now, what you see here expressed with single quotes, guys. So, let's call it a single quote like this. Character assignment is done with single quotes, guys. These are characters. For example, let me write system out, let's say character, or let's add a plus so at least it's visible. What should we say? For example, the last one was 6. The character 6, okay. I wrote it like this. Now, when I run it, you'll see the character 6 at the very bottom. This is the character 6. So, what will we see if I do it like this? Character equals. What did we say it was numerically? Was it 98? I assigned the value 98. Look, this time I assigned a numeric value. So, I assigned a numeric value to the character. Think of it this way. I said when you press B on the computer, the value 98 is sent. Right, with ones and zeros. I gave the situation directly here. I said, send 98 to the character. So, let's write it now then. For the value 98, character, let's say plus character. Let's see what comes out when we print it. Look, the letter B appeared. Guys, where did it come from? Where did it come from? It came from here. When storing information in a character, basically, what kind of information does it hold? Guys, the numerical value you provided. So, in the background, it actually stores that numerical decimal system. When you print this as a character, it displays the character corresponding to that value on the screen. If I had assigned this to an integer, it would have shown 98 directly. So, what variables actually do is this, guys. The only things you can store in a computer are ones and zeros. Nothing else. Will I interpret the numerical value formed by the combination of ones and zeros as an integer, or as a character, or as a float, double, or something else entirely? Variables are what determine how you interpret it here. This is actually what variables do. Yes, they store data as ones and zeros inside, but when you're writing or using the application, you don't need ones and zeros. You need characters. You need digits, numbers. Or there will be other things you'll need. You need those things. You need logic gates. And what do you need to be able to convert these? You need these variables. You need variable types. A character variable is just like this, friends. If you assign a value to a character variable when you want to read or print it, it will display it on the screen in this way, friends. Alright, there's nothing too complicated about this anyway. It's also pretty simple to use. We'll talk later about where these are basically used and consumed. Right now, we're just becoming aware of their existence. We're not coding yet, we're just building awareness. After a while, we'll start using these. So, don't rush, okay? Don't think too much about where this will go. We will be heading towards very good places. Be patient, as clean as possible. I'm trying to explain less. I don't want to tell a long story, so clear information, clean information. Then we will continue by building on it.